Okay, right. So I am going to sort of use a coin and then correlate it with our inspection or batches that we were talking about in business to sort of give you some relationship um, between the math and how we apply it in business. Right. So what I'm going to do first is I'm going to say to you, I'm going to draw these things called tree diagrams. You might have come across them, but they're pretty smart little things that you can quickly sort of see. So typically, I'm going to start off with the coin. I'm going to start talking about I'm going to start off with a fair coin. Because when I say a fair coin, the chances of getting heads are just as even as the chances of getting tails. So I'm going to toss up my coin once, right? And because it's a fair coin, I would argue that there's a half chance of getting either. And what I'm trying to do here is I want to know what is the chance. What is the chance? And when I say what is the chance, I'm really saying what is the success of me getting ahead, right? What's the chance of me getting ahead? So I toss up my coin the first time, the only time, for example, in this scenario, I could get a head or I could get a tail. And that's 0.5 and that's 0.5. And that's a very nice simple scenario that if n is equal to 1, I toss up a coin once. What are the chances of me? What is the success of me getting one head? Well, the success is 0.5. And therefore, if success is a head, well, failure is a tail, isn't it? And the failure is also 0.5. Right, I could move this on a little. I could just go one step. I could say, I have always wanted to know, I could change my color here. Let's change the color. Let's see. Right, okay. So I could have a scenario and say, okay, you know what? If I tossed up a coin twice, right? And every single time, remember we talked about independence, the fact that just tossing up a coin twice, I mean, the fact that I tossed up a coin twice doesn't change that every single time I toss it, that the probability will be 0.5. And the probability of tossing a coin up and getting heads or tails, really, the probability on the first turn, first toss really is 0.5, and that's what I'm really using. But the key point is the probability is always 0.5. What is the success? I could do a range of things. What is the success that I will get 2 heads? Right? So if I toss up a coin twice, what is the success? I will get 2 heads. Well, now let's look at it. The first time I tossed the coin up, I could get a head, I could get a tail. Then, after tossing the coin up the first time, so I record what happened the first time I tossed it up, right? First time I tossed it up, I could get a head or I could get a tail. The next time I toss it up, again, I could get a head, or I could get a tail. I mean, that's just what it is, right? 0.5 or 0.5 in terms of the tail. And in exactly the same way, on this other hand, when the first time I tossed it up, I could have gotten a tail, and then the second time I tossed it up, I could get a head, or I could get a tail, which is 0.5 and 0.5. So now, let's look at this. This is on me tossing my coin up the second time, right? Or twice, if you like, where a total, n is equal to 2. Total 2 times, success of 2 heads. Well, the success of 2 heads is really this one, isn't it? 2 heads. So the success of 2 heads, and with these tree diagrams, what we do is, and we'll see why it makes sense in a second, is to therefore say, well, the probability of getting 2 heads must be 0.5 times 0.5, which is 0.25. Now, this is 2 heads. I mean, here, I have a head and a tail. So my success, I could have asked the question, what is the probability of me getting a head? 1 head. Well, I mean, I have a head or tail, so I mean, here I have 0.25, which is 1 head. Here I have 0.5 times 0.5. So first I had a tail, then I have a head. I mean, it's still 1 head. It's just arranged differently. And here I have 1 tail and 1 tail, so here I have no heads. Right? So here I have no heads. Oops, sorry, I don't know if I on my pen. Here I have no heads. Here I have one head. I have one head. So the probability of getting two heads is 0.25. The probability of getting one head, well, it doesn't matter what order. The point is the probability of getting one head doesn't matter whether I got the head. You don't care. You don't care if I got the head first or I got the head second. The point is that I got a head. So the probability is to add these two together, which is 0.5. And the probability of getting no heads, which is the same thing as the probability of getting two tails, right? Because it's tail and tail, no heads, is 0.25. Like I said earlier on, all probabilities must add up to 1. So 0.25, 0.5, and 0.25. And so, what we have here is this kind of, let's come back here to this. You sort of understand that this must sort of be true. The probability of getting one head, a head, if you toss up a coin several times, because everything's independent, will still always be half to a certain extent. The more and more you toss it up, you're always going to approximate half, aren't you? And so the probability of getting either two heads, and you can see these two look alike, because the probability of getting two heads is the probability of getting no tails, or probability of getting two heads, the same thing as the probability of getting two tails, right? So that's kind of how this thing builds. Success, we can choose success. I could have said, what's the probability of getting at least a head? So a probability of getting at least a head is the probability of getting two heads and one head. So that would be all of this plus all of this, right? So again, relating this to business, if I had two items and I wanted to know what is the success of success could have been, could both of them be defected? Could there be a problem with them? And the probability, again, depending on, the circumstance, like I explained in my earlier videos, the circumstance, P will be different based on the circumstance. This could be rain or sunshine, but P would be based on our previous knowledge and history of the data, of the information. If it was purely a half, this would be exactly the same scenario, right? The probability that both would be defected, if success was to find defection, or to find a problem, a defect, if that was success, or if the probability was full. It doesn't matter what it is. Let's just say P is defect, and therefore the other one is not defected. The other chance is not defect, is to have no defects. It would be exactly the same sort of same scenario. This is the probability of having one defected and one not defected. That's 0.5, if you like. The probability of one defect is 0.5, and no defects would be 0.2, 0.25. So both defected, one defected, no defected. Exactly the same scenario. I could extend this, and I'm going to in the next video, just to build it, to make sure you're happy with this. Okay, see you in the next video.